I'm the VP and head of bio-oncology, U.S. Medical Affairs for Genentech, and I'm also a professor of medicine at Mayo Clinic. But before I start talking with you about personalized medicine and what we're doing about this and how this will change the practice of cancer care in the U.S., I thought I would tell you a little bit about who I am and why Leanne invited me to be here this afternoon. You know, breakthroughs, innovation, personalized medicine is part of my DNA. I've been involved in clinical trials that have led to approval of some agents that are used globally to improve the likelihood of benefit for women with breast cancer. In addition, I'm very passionate about involvement with the community, so I started the Breast Cancer Marathon, the only national breast cancer marathon in the US with one of my patients. Additionally, I've been so fortunate to get some awards by different people. Leanne gave me the opportunity to speak at the Lesbians Who Tech meeting that we had at the Castro Theater in San Francisco, which was really cool. But added to this, after a career at Mayo Clinic where I had various jobs, including deputy director for the Cancer Center, I decided to join Genentech a year ago while maintaining my academic career at Mayo Clinic. And so lucky, I moved from Florida to San Francisco, where it's a great place to work, a great place to live, not only because of the place itself, but because I can be with friends, including my wife, who happens to be in the third picture there. So it's good, it's good stuff. But now let me get into the main topic of my conversation with you for the next 7 minutes or so. You know, cancer is a huge problem. It affects individuals, families, friends. It's a local problem for the US, but of course a global problem. Too many people are diagnosed with this disease every year. You know, here in the US, more than 1.5 million people every year. At the same time, many people are successfully treated every year, leading to more than 10 million cancer survivors living in the US right now. However, there's much more work to be done. And personalized healthcare is part of the solution and will increasingly be part of the solution in the years to come. So you may wonder, well, what are you guys doing about cancer research and personalized medicine today? Well, we are developing treatments based on molecular or biological abnormalities of cancer by interrogating thousands of genes, whether they're normal or abnormal. We're looking at thousands of proteins and how they interact with each other. And we're connecting this with personalized medicine, utilizing not only the paperwork that you show in the previous session, but really incorporating digital health. So you may wonder, how are you connecting digital health and personalized cancer care? So we think there's a total interaction between health and technology to improve prevention, screening, as well as outcomes of persons who are concerned about or who are diagnosed with cancer. So the idea here is to utilize data, analytics, connection, and patients' own information so that we can aggregate the data for decision-making to improve clinical outcomes. And there's a cartoon that actually shows some of the ideas behind this concept. So what we want to do is to catalyze precision medicine and precision oncology by linking clinical, retrospective, and prospective data or information, as well as longitudinal clinical outcome based on the information that we directly can receive from patients on a day-to-day basis. So you may wonder, well, what does this really mean? So what that means is that we need to understand the true biological abnormalities in the genes and proteins. Then we utilize that information to predict whether a person is likely to benefit from one treatment versus another. We can do potentially some repositioning of some of the agents or medicines that are already available. So we might identify newer groups of patients who might benefit from these older drugs because we've been able to better understand the biological characteristics of their tumor. And lastly, but not least important, we think that by this connection of digital health with molecular understanding of cancer, we will be able to identify new molecular markers that will allow us to develop better medicines to treat people. There are many, many companies that are trying to get into this arena. Certainly, we've heard from many of them during this fantastic meeting, and I just listed some of them on the lower part of my slide, including the recently announced Microsoft Hanover project that was announced just a couple days ago. Oh, hi, Edith. As well as the Moonshot project that has been galvanized by Vice President Biden. So I don't know how many of you are involved in medicine. Maybe a raise of hands. Okay, some of you. Okay, great. It's a good slide for all of you. Because this actually gives you a little bit more granularity related to what I am thinking about when I talk to you about our ability to understand biological or molecular abnormalities of cancer to get to an improvement in personalized medicine. So we can go from the left to the right or the left or vice versa. But you all know that we have about 25,000 genes in our bodies. And you know also that many of these genes get transcribed into proteins, and the intermediary is called RNA. Okay, I have some nodding here. Come on. Yeah. You all went to high school at least. Come on. So these days, actually, we do have the ability to interrogate these 25,000 genes to see if there are mutations, no mutations, whether there are extra copies of one gene versus another. We can certainly study RNA, and we can certainly evaluate protein expression. And today, we're actually utilizing those tools to help with the diagnosis of patients with cancer, to help screen patients who are at high risk for potentially developing cancer. And we're using some of this information to decide on therapies for patients. But even this field is evolving very fast because the technology, with the help of all of you, is also advancing very fast. So we're getting better and better at our ability to understand these biological abnormalities, not only in tissue, but also in blood. And this is something that is very new in the field, because in the past, we had to obtain tissue specimens to be able to do molecular analysis. And one of the areas that is changing is that we're trying to figure out if we can use blood specimens to also analyze genes and protein expression to help us optimize personalized cancer care. Certainly, many new radiological techniques are also being incorporated into this field. But besides our ability to interrogate tumor specimens, interrogate blood specimens, we're also very interested in harnessing another part of our body to conquer the problem of cancer, and this is harnessing the immune system. Essentially, there are 3 types of immune activities in the setting of cancer, and I'm demonstrating them to you as these cartoons here. There are tumor cells who do not have any immune involvement trying to attack the tumor. There are some tumors in which there are some tumor cells, but they don't work too much in correlation with what's happening with the immune system. And in some tumors, actually, the immune system is trying to do something and does something. But even with those tools, it's just not enough to kill cancer. So we're taking a connection between personalized healthcare with the interrogation of biomarkers and also harnessing the immune system, and for them to work together to improve the care of patients with cancer. This is really great. So as my slide, full slide of numbers and data and words, we are truly incorporating digital connected health and precision biology in cancer. There are many different definitions to digital health, but we're incorporating all of them. And with this information, with your help, there will be many more than 10 million cancer survivors in this country in the years to come. So thank you very much.